Welcome back. So in the previous lectures, we looked at the fundamentals of inventory. We looked at the basic relationships, for example, safety stock, reorder level, reorder point, as well as things like economic order quantity or your reorder point, and more advanced concepts like service level as well as the fill rate. And in this lecture, I would like to apply those concepts on a more concrete real-world dataset. So here we have an example of a real-world dataset, and this can be coming from any ERP system like SAP, Material Management Module, or anything similar. And the idea here is that basically we would have two sets of information for our items or SKUs. We would have it at a meta level or a metadata level, as well as on the transactions level. What I mean by that is, for each of these items we would have information such as item description, item average lead time, any other characteristics of the items, and so on. So these would be your meta details or information about the item itself. And then also the transaction information, for example, how much of the items we ordered, let's say on a certain date, how much of it was received. And there can also be information on the other vendors. For example, if this item is supplied by multiple vendors or suppliers, we can have a column for the vendor, for example, and then compare the delivery times and then find the standard deviation on the lead time itself. But in this lecture, I would like to keep things simpler. So we have our columns as SKU ID. This is the ID for the item. We have the order date, we have the quantity ordered, we have the receive date, as well as the lead time in days. So what do I want to achieve at the end? So what I want to achieve is at least build a table of preliminary analysis on the inventory with things such as what would be my safety stock for each of my SKUs, what would be my average daily demand, what is my variation in demand, what is my average lead time, what would be my reorder point, and what would be my reorder quantity. So we are essentially applying the same models or the same formulas which we have seen earlier in this particular case. And what we want to do is we want to first restructure the data and then apply those models which we have seen earlier. For example, this particular Python function creates the safety stock for the particular service level, variation in demand, as well as the lead time average, as well as this formula which creates the reorder point. So let's look at this in a more concrete sense. So let's start with first grouping the data by the SKU IDs, because this is actually our primary key. So this makes more sense to group it by the SKU IDs. Next up, we'll find the average daily demand by SKU. So this particular operation will generate a generic group by pandas object, which can then be used to perform operations such as group by sum operations over certain columns, such as quantity ordered, as well as performing operations with pandas datetime objects. So in summary, we'll take SKU groups object and we will sum by each SKU and divide it by the date interval or the number of days. So for example, if we had demand for 3 days, so 7 plus 5 plus 4, this will just divide it by 3 to give you the average demand. And then we would rename this column to average daily demand. Then we will perform a similar operation to calculate the standard deviation of demand per SKU. And if there is an issue or there is an error in the calculation, it will fill it by the 0 value. So this is going to fill the NAs by 0 value. Such as if there is only one order, there is obviously no standard deviation calculation. So that in that case, it will be giving a result of 0. And then we will rename it to demand standard deviation. Then in step 4, basically, once we have completed these, we will have our average of demand per day for a particular item as well as the standard deviation, and we will basically merge these two things together into a pandas data frame. And next up, in the next step, we will basically require to calculate the lead time average. So if you remember, the formula for safety stock was Z times sigma times square root of LT. So we have the Z because it's a probability function based Z score. We have the sigma, which we calculated here, and then for the average of lead time, it will be coming from this particular calculation. So once again, to give you an example, basically this table would be created as SKU 001. Let's say this is the number, so it will be, let's say we have 3 rows and we have 3 values of lead time. So in that case, the order would take, let's say, 5 days, 4 days and 1 day. So the sum of this will be 10, let's say. So 10 by 3 is 3.33 would be the average lead time for this particular item. And next up, once again, we will merge these 3 metrics together using this particular piece of code. And next we have the formulas or the functions for safety stock, which we have seen earlier in the course itself. And this is basically returning the same formula which we have seen earlier, which is Z times sigma times square root of LT, which is this particular relationship. And if this thing is 0, so the whole thing is 0, and we are programming it here using this particular if condition. And this particular relationship or this particular piece of code just applies this relationship or this formula or this function to the set of columns called demand and deviation and average lead time, which we have calculated earlier. And it's done using something called as lambda functions, which are basically inline functions or headless functions, which can be used with the applied pandas function to be applied to the whole column. So here once again, this matrix is a data frame, apply is a pandas function, lambda means start of the lambda inline function, row is your variable, and this is basically your function which is being called from here basically. And this is the columns which you are going to apply this function on. And next, let's look at the reorder point function. And reorder point is the inventory level at which a new order is triggered to avoid stockouts, as we have seen earlier. And this function will take basically 3 parameters of average demand, average lead time in days, and the safety stock, which we have calculated in our earlier part. And the formula is similar to the one we have seen earlier, where you have the average demand times the lead time, plus we are adding the safety stock. To calculate it, we will apply it in a similar way we did for the safety stock. We'll use the apply function and the lambda inline function to perform the calculations based on this particular function. So for example, it will take into the account the average daily demand, which we have calculated earlier here in this part, as well as the lead time average, which you have calculated here, and then this will be applied in this particular way to calculate for each of the different items. Next up, for the reorder point or the EOQ, we have basically applied the same formula we saw earlier, which was basically square root of 2 times ordering cost times your annual demand over your holding cost. And since we need to have some values for the holding cost and ordering cost, I'm assuming these figures, but basically these will be based on your business costs. So for example, ordering cost can be based on your complete set of costs, like your administrative cost, your technology cost to manage different orders, procurement systems, etc., etc. So it is all based on those costs applied over the full set of year, let's say, and then divided by how many how many orders do we expect over a period of, let's say, 1 year. And holding cost is also similar. It's based on generally the capital we spend on the warehouses, the rents for the warehouses, etc. So we take the same data frame, we create the column called reorder quantity, and we apply this formula here to calculate the reorder quantity for each of those particular different sets of SKUs. And once that is done, we have completed a majority of our work. So we expect our data frame to be something like maybe this is our item SKU, and we will have then different characteristics. So we'll have our safety stock here, we will have our reorder point, we'll have our EOQ here, and so on. So then these values can then be put in some sort of your ERP system or your management system to perform optimizations across the year. So if I scroll down here, this is our output, and this is what we have achieved for each of these items. And as part of my final notes, although this code is more general and basic, but this can be applied to all sorts of real world inventory data sets or data frames, and can allow you to perform quick optimizations on your inventory.